Hi guys, welcome back. We're going to look at perimeter and area in the coordinate plane. So we're going to start off with polygons. A polygon is a closed figure, so there's no openings, formed by three or more line segments called sides. Each side intersects exactly with two sides, and so when I meet two sides that meet at that point, we actually call it a vertex. So there are no two sides with a common vertex. So you can see in my picture here, I have labeled D as a vertex. Each one of these are vertices. We're just showing that D was an example of one. C, D, D, E, E, A, B, C, and B, A, they're all sides of this polygon. And how to name this polygon is we go in consecutive order, which means one right after another, and we tend to go in alphabetical order. So notice I named this polygon A, B, C, D, and E. They are all capitalized letters. So when we are naming, we still are using capitalization for our letters. All right, let's look at our table of terms. So some of these terms you may be familiar with. You are required to know this table. There are other terms that I will highlight, but you're not required to know them. So this table is very important to know. The number of sides determines the name of the polygon as shown in the table. So 3 sides is a triangle, 4 is a quadrilateral, 5 is a pentagon, 6 is a hexagon, 7 is a heptagon, sometimes also referred to as septagon. 8 is an octagon, 9 is a nonagon, 10 is a decagon, 12 is a dodecagon, and then notice I skipped over 11, so we really don't pay attention to 11 that much. 11 is a hendecagon if you're curious, and then anything after 12, we refer to it as a gon, n-gon. N will be represented by the number of sides. So if I have 13 sides, it'll be a 13 gon. If I have 100 sides, it'll be 100 gon. So here I have 17 sides. What would the name be? Right, it would be a 17 gon. Notice I wrote the number 17 and then G-O-N afterwards. Again, you need to know all the polygons in this table. All right, a few more vocabulary terms. We have convex and concave. Convex, it states a polygon in which no angle is pointing to the interior of the polygon. Concave, a polygon in which at least one angle points to the interior of the polygon. I'm not a fan of these definitions, so how I determine if I have a convex or a concave polygon. So here's my two examples. So you can see here that I have a polygon here with a four-sided figure. Notice how I'm hovering over with my mouse the four-sided figure. So I'm going to show you how to determine that this was convex and how this polygon to the right is concave. So what I like to do is I actually like to take my highlighter or pen or pencil and extend my lines, aka my sides, to see if the line will go through the inside of the polygon or not. If the line happens to go inside the polygon, anywhere on the inside, well then it's concave. If it doesn't go inside, then it's convex. So if you actually look at the very first one, and here's this side, if I trace over this side, it doesn't go through. If I trace over this side, it doesn't go through the interior. And if I continue that out to the remaining two sides, it doesn't go through the interior. So that is convex. In my next example, I'm going to start at the top and go trace over. So notice that side does not go through the interior. This little side, if I trace up and down, it does not go through the interior. And I travel all the way around. And then when I come across this top piece here, notice if I extend my line, it actually goes through the interior. And I'm going to stop there. And I already know that now I have a concave polygon. All right, so let's look at some examples. So here I would like you to try to classify each polygon by the number of sides and then tell whether it's convex or concave. All right, so let's look at the very first one. We have 1, 2, 3, 4 sides. If I have 4 sides, what do I call that polygon? Right, we should call it a quadrilateral. I'm just going to abbreviate quadrilateral with quad. Right, I'm going to continue on naming our polygons with our names from our chart first, and then go back and name it convex or concave. All right, our next example. Count our sides. 1, 2, 3, 4, 5, 6. 6-sided polygon. We call that a hexagon. Right? Now the next polygon. 1, 2, 3, 4, 5. What is a 5-sided polygon? It is a pentagon. Right? And then the last one. 1, 2, 3, 4, 5, 6, 7. What is a 7-sided polygon? It is a heptagon. All right, now we're going to look and see if it is convex or concave. So this is when I want you to take your pen, pencil, or highlighter and try to trace over your picture. Remember, you're going and elongating each side to see if it goes inside our polygon. All right, so pause your screen and then try the following problems. All right, so let's see the first one. The first one we can go through and highlight over, and notice when I get to this side right here, when I go over this side, what happens? Right, it goes through the polygon. So since it goes through the polygon, it is concave. All right, then we have our hexagon. So our hexagon that we already identified, if I go over my sides and elongate them, does it go through? Right, it does not go through, so we call this convex. All right, then my pentagon, you could see already, I could see this line, if I elongate it, it's going to go through, so this is concave. And then last but not least is my heptagon, and if I elongate these sides, you can see it doesn't go through, so it is convex. All right, let's look at the next slide. So now we're going to touch upon finding the perimeter and area in the coordinate plane. Remember, perimeter is the total distance around the figure, so as if we're finding each length of each side, and we label that with units. And then the area is the space inside of the closed figure, and we label that units squared. So feet squared, inches squared, whatever the units is squared. Some of the typical formulas that you should be aware of are in this box here that I put. We have our triangle, our square, and our rectangle. To find the perimeter of our triangle, we add up all 3 outside lengths. For our square, we're adding up all 4 sides, but notice that they put 4s, 4 times s, because each side has a tick mark. Remember, the tick marks mean that the sides are congruent. So I know all the 4 sides have the same length, so I could say 4 times the length of one side. Same goes with the rectangle. Again, we have our tick marks on our diagram. I have 2 tick marks here, so I know that the widths are the same, and then the lengths have double tick marks, so I know the lengths are the same. So I could say 2 times the length plus 2 times the width is my perimeter. And then we have our area formulas. Area of a triangle is 1/2 base times height. Area of a square is side squared, or side times side. And the area of a rectangle is length times width. You should be aware of these formulas. These ones you will see quite often. Now remember, we need to find our distance, so we need to find the length of each side. To find the length of each side, we're going to use our distance formula. So let's look at the next page. All right, so it says find the area and the perimeter of each polygon. So we start off with 4 points given to us, and we want to graph them on our coordinate plane. Remember, this is coordinate geometry, so they want us to plot it on our plane, so please take the time to do that while I do the same. Remember, you want to label your points, so I labeled K, L, M, and N. And now we want to find the lengths of each segment. Now remember, we want to find those lengths. So to find the length, we need to use the distance formula. So the first thing I want to do is identify the order pairs I'm using. So for KL, I am using the points from K and the points from L. Notice again, I stacked them on top of each other, and I'm plugging into our distance formula. So now I would like you to try the distance formula. Remember, that is the square root of, and then we take our x coordinates and subtract, then square, plus, and then the same for the y's. Subtract, then square. So here is my order pair. I'm going to move that to the side, and you can see my work. So when I plug this into my formula, I find the length from K to L is 5. Now I could check that because this is actually a horizontal line, so I can actually count those boxes. So I can see 1, 2, 3, 4, 5. My length is 5. Now you're going to do the same thing for LM. What points are we using for L to M? We're using for 1 and 2, -2. And we're going to find our length. Again, using length, we're finding the distance. So we're using that distance formula again. All right, so here the distance is not a perfect square, so you can see that we'll have to round. So the length from L to M is 3.6. All right, so I'd like you to try the two down below, and then I will show my answer. So pause your screen and try MN and NK. All right, so MN, here are my 2 points that I will be identifying, and I stacked them. And then my formula I plug in and find the length from that, from M to N, is 5 units. I hope you notice that I'm actually labeling out the length for each segment because, again, we're not done. We have to find the perimeter and the area. So those lengths will be important. So you want to stay organized. All right, now NK. Here are my 2 points that I'm using, and here is my work. So I have 3.6 again. Not every time will you have the same lengths for every segment, so please be mindful that this just happened because of our quadrilateral that we're dealing with. All right, so we have a 4-sided figure, and we want to find the perimeter. So to find the perimeter, we are going to add up the lengths of all 4 sides. So here is my perimeter. 5 plus 3.6 plus 5 plus 3.6 equals 17.2 U. Now, I put U because it's units. They didn't tell us what type of measurement. So we want to make sure that we're including the units that should be there. Now, the area, how we find the area of this figure. The area of this figure is base times height. So now my question in this problem is, did we actually find the height in this problem? Think about it. All the sides that we found here at the bottom, that's the base. Here, is that the height? No, that's a diagonal. Our height is up and down. So this actually, we have to pause for a moment and think about where the height is. So I'm just going to get a shape over here. So I want you to see that my height is where I stand up tall from the top to the bottom. So I'm looking at point K. And if I drag that down, this piece right here is actually my height. How many units is that piece? Right, it's 3. So here I'm multiplying 5 times 3, and that is 15 units squared. So please be mindful that sometimes we may or may not have the height calculated for us, and we have to go back into that figure and find it for ourselves. All right, last one to try. All right, pause your screen, try this one on your own. You're going to start off by plotting your points and connecting to figure out your shape. Then you're going to find the length of all the sides. I actually took the time to identify each side for you. You will be able to do that on your own later on. And then you're going to find the perimeter and the area. All right, so let's look at what we have. So when we plot our points, you should come up with a triangle. So now we have 3 sides of our triangle. We have DE, EF, and FD. So for DE, we're using our first 2 points. And when we plug in, we have the length of 7. Right? Then we have EF. The length is 5. Now, these 2 sides are great because it's horizontal and vertical, so I could also count boxes. Distance formula will never fail me, but when I have a horizontal line, I can count those boxes. From F to D, I cannot do that. I do need the distance formula, and you can see that the length is 8.6. Now, to find the distance around this triangle, we're going to add up all 3 sides. And when we do, we have 20.6 units. Again, do not forget to label. Now our area formula for a triangle is 1/2 base times height. So we only need 2 numbers. Now we have to identify our base and our height. So this diagonal is never our base or our height. So I always assume the longer part down here is our base. So that means our triangle is flipped upside down. So you can see our base and our height are these 2 sides, which we already found. So that was 7 and 5. So 1/2 times 7 times 5, we have 17.5 units squared. Remember, it is okay to have a decimal as a solution. All right, good luck with practicing.